Okay. Welcome everyone at my talk about Microservices visualized, um, a story of managerial fears and analysis paralysis. What's in the title, right? So today I'm going to talk about microservices, some of the benefits, mostly about the pitfalls, and how to make sure you don't end up in those pits. So first of all, the story begins in a traditional model, which is the monolith. Who knows about monoliths? Almost everyone. Okay, that's great. So this looks like a monolith, right? I mean, it's kind of a monolith with the adapter pattern, which is already pretty nice, but it's still just a monolith. So everything's kind of centralized in one big application. Everything's deployed on an application server, and then that's like you can scale that, but complete as one application. So that's kind of where we came from. And while we were doing this for many years, we kind of ended up seeing some downsides to this. One of the downsides is that you kind of have a long way from inception of an idea towards production, right? So to get to a production, we kind of have these release cycles that often take 6 months, a year, sometimes longer, and that's really putting pressure on business because sometimes when they think of something and they think it's a great idea to better off their competition, then once it's in production, it might not be a good idea anymore. Maybe it's not useful anymore, right? Because it takes so long and the market evolves. Okay, so getting it in production fast is one of the most important things these days in our economy. And with a monolith structure, that's kind of hard to do because everything's one application. And if you change one thing, you gotta change everything. And if you have a little change somewhere, the consequences are big. You gotta test everything, right? So it's kind of the idea of the butterfly effect, and you don't want to go there because basically because of this, because of the monolith, you kind of end up in release cycles. You have to have 6 months because you have an army of testers. Kind of have to test everything every time again. Not much is automatically tested often in a monolith. So it's pretty hard to go faster if you have such a structure. Okay. Then aside from going faster, you also sometimes want to scale. And scaling is difficult because with these traditional applications that are deployed on an application server, you have to first provision the application server, put the application on there, and then you can actually scale up in that sense. But provisioning the application server often takes manual processes, a ticketing system, whatever, and sometimes takes weeks, sometimes months to get this extra server in place. So that's very difficult because while you might know that Christmas is coming up and your e-commerce website will have a lot more traffic prior to Christmas, you can scale up yourself, you can plan for that. But what if you're mentioned in the news, for instance, then that might be a peak in traffic that you don't expect. So you kind of want to really be agile in that sense. And cloud helps you with this, but if you have this one big monolithic application, it's kind of difficult to achieve altogether. So this is why, this and many other reasons, by the way, it's why people begin to talk about monoliths as monolith monsters. It's really kind of a tough architecture to be agile, to go fast. Okay, so we gotta have to look at other ways of implementing our architecture, and one of these ways that came up recently, well, a couple years back, is microservices. So let me first ask, who has heard of microservices? Wait, who hasn't heard about microservices? Okay, and who hasn't implemented microservices yet? Okay, so most of you have heard about it, but not experienced it. Okay, basically, the concepts, you're probably familiar with that. You put your application, you divide it in bounded contexts. So you have these functional boundaries, scope of a particular part of your application, where, for instance, you have the driver, you have the trip, you have notifications, payments. These are all boundaries, bounded contexts in domain-driven design. and they talk to each other over a protocol. So that's different from the monolith because you no longer call different parts, well, the different parts of your application don't call each other anymore in the same process. They now call each other over the network. So there you have a much stronger boundary between the components. And that boundary is important because it's kind of the sacrificial architecture that Martin Fowler talks about. So with sacrificial architecture, you kind of accept that you won't build an application which will withstand the time forever. So that's what we've been doing normally with the monoliths. We kind of saw that our monolith is growing too big. It's becoming a legacy application. So we put a Tiger team in charge to build a new application. And now let's predict everything that's coming up. But after 3 or 5 years, we see the same thing again, and you have to rewrite everything again. So with this model, it's sacrificial because you know that there's going to be a time where you don't need this framework anymore that you're using. Or you need another language altogether, or maybe just there's different functional requirements. So in that sense, here it's much easier to swap out a little part of it because the contracts are much better defined. They're defined with contracts over network, right? So you can just plug them out. They're independently deployed, so you can just scale them up or scale them down. Okay, so this way, it's a much more different approach than a monolith. In a monolith, you can still be modular. You can build a modular monolith by packaging things correctly, but still you have this one platform, one language, one framework, and that limits you in some sense. So you have some pros and some cons. So pros, strong module boundaries. Okay, so teams can focus around one specific functionality. They don't have to know everything. It's a lot more complex if you have to know everything of your entire system, and your model becomes easier as well. So an anti-pattern in microservices is to have this one big domain model, okay, which is trying to solve everything. Now you can focus your complexities to the context you're in, to the microservice you're working with. You have also independent deployments, which is great because basically you don't have to test everything. You don't have to wait until everything is in order to deploy. You don't have to deploy everything at once. You can just make your change in one microservice. And you can put it on production by deploying that little microservice. You have technology diversity. So basically, you can choose whatever tool, framework, and language you want. You have security segmentation. So in the banking sector, for instance, you have a lot of security needed. But that security is adding a lot of complexity on your application as well. So normally what you do is you just put it on your application and everything becomes more complex. But with this system, you can say that, for instance, accounting becomes more secure, or billing, or whatever is sensitive. You secure that, you add complexity on that microservice, but maybe marketing microservice or whatever, which is not really important to be secured, can have less complexity and is therefore easier to maintain. Okay, so that's a benefit. Then we have separate scale out. Obviously, you don't have to scale everything at once, so you can scale just the piece that needs to be scaled with the piece which needs traffic. And parallel development. So your teams are more focused, but they are also more separated from each other. You have DevOps teams, which can work independently from each other because they have contracts which define the way they have to communicate with each other. Okay, so you don't have to put everyone together anymore. Inside your team, inside your DevOps team, yes, everybody has to be together, ideally. But those DevOps teams can be even in different continents. That doesn't matter, because they also work with each other over these contracts, which they agree upon. Okay. So parallel development, because they can work separately from each other, they're not dependent on each other anymore, and therefore you can have much more output, much more functionality getting done. But there's no such thing as a free lunch, right? So there are also downsides to this architecture. There's no architecture which is only solving things and not actually introducing more problems. And microservices is just the same. It also has downsides. And if you work with an architecture like microservices, it's really a lot more complex. The distribution. So if you pull chunks out of your application and put network in between, you start to build a distributed system, right? And the first rule of distributed computing is don't do distributed computing, because it's much harder than if you just work in process. Okay, so distribution is really a downside to microservices, but it enables all this stuff. Okay, so if you want to go faster, if you want to have a flexible architecture, this is great, but don't forget about the distribution. Okay, distribution adds a lot of complexity, and especially operational complexity. So you have all these different components, these microservices floating around, which could go down at any given moment, which basically put a lot of pressure on operations. So here as well, make sure you have a DevOps organization if you want to do microservices, that your team is building and running microservices and not just throwing it over the wall, so that they're actually concerned about the operations while they're implementing it. Okay? So that's a different approach, different mindset, which really is important in microservices. And then the one I didn't cover yet is eventual consistency. Now, who has heard about eventual consistency? Okay, about half. It's kind of the idea of let me kind of try to put a context around that. You have your microservice, and you have different microservices, and you have a database, right? That's kind of how you normally have your application, your monolith application, and a database. You put your schemas in there if it's a SQL database, and all your data is connected by foreign keys. Now, what you want to do with microservices, you don't want to put all that data together in one database. Why not? Because if you want to change that schema of the database, then everything's it's impacted. All these different microservices, you got to change them all, and you got to deploy everything together. So what you get, it's just the same as a monolith. It's just a distributed monolith now. So you have all the downsides of microservices, but you still have to deploy everything together, which is neglecting all the benefits, so you don't get the benefits. Okay, so what do we need to do? We gotta put our database in pieces. We gotta slice it up. Okay, we gotta put the data also in the bounded context, so in this strong module boundary. Okay, so you have a microservice, for instance, about trips. I think one was on the slide. So you'll have a database about trips, and there will be a microservice about cars. You have a database about cars. Okay, so now you have two different databases. Okay, you don't have any foreign keys anymore, but you still need to have a relation between this data. And then the question comes, what do we do in that case? We can either do distributed transactions or not. I think most people will agree distributed transactions is a path you don't want to go to, because it ends up in hell. So if you don't have distributed transactions, you don't have asset anymore, and then you basically become eventually consistent. So your data is not consistent anymore because it's living in two places and it's not up to date. There's a sync job between them probably, but that sync job is asynchronously, which means that it's not up to date at all times. So you're eventually consistent. And there you can find solutions like event sourcing and that stuff, but still it kind of adds complexity. However, if you're looking at your current application, it doesn't always have to be a special scenario, eventual consistency. If you load a web page, if you just go to any page on the web, then what you see, what you're presented on your browser, is an eventual consistent page. It's not consistent anymore because you see an older version of the data that's living in the database. You see a snapshot, right? So while analysts are often looking towards a feature that they want to implement, and they say that this has to be real time, because why not, right? It's much cooler if it's real time. It's better. Everything's nicer with real time. True, but you add complexity to the system, and especially in microservices, you add a lot of complexity. So why not just accept that you're eventual consistent? And most of the scenarios will just be fine with that. Okay, so that's a different mindset. It adds complexity because it's microservices and it has that as a result. But still, it's if you embrace it, you'll get much further with working with agile methodologies. Okay, you'll get much faster to market. So you see benefits, downsides. If you can't build a monolith, these downsides are going to kill you. Okay, so if you can't build a monolith, what makes you think microservices are the answer? Okay, that's a great question. These things, these microservices that we're trying to build, they also have to be clean code they have to follow the solid principles. Right? They are kind of the next step in software development. So if you can't build the first step, it's kind of hard to jump into the next step. Similarly, if you don't have a DevOps organization, if your culture is lacking behind, you're gonna have silos, which are kind of the other way around, the other direction of the functional boundaries that you want to create. And those technical silos, they will block your development, and you won't go fast. You'll just have a great architecture, but no results. Okay, so take that in mind. Okay, so now we have some clients where we do microservice, obviously, and what we sometimes see is that developers like this a lot because they can use the latest tools, the latest frameworks, even the latest languages, and they have small code bases, often new code bases. So they kind of become these space cowboys. Okay, they're let free. This feels great, right? I love microservices because I'm a developer, right? So I kind of see that as I can do whatever I want. I have a playground to play in. Okay, there's no consequences. But management sees that this is a big risk because, I mean, you kind of have all these different things that are unmanageable. Different frameworks, different versions, different tools, different languages. All this stuff, I mean, how are you going to recruit and all that stuff? I mean, it becomes really unmanageable. So managers, on the other hand, they see their entire IT infrastructure or IT organization completely go to ruins. Right? So they're afraid. Right? Microservices, I don't know. So what we want to do is microservices is a great way of building applications. I mean, if your organization is fit for it. But we kind of want to help the different stakeholders in the IT organization to cope with the complexity and with the new way of working of microservices. So we kind of have to think about them, because if we don't, then we're going to have a great architecture which is going to blow up in our face, and management's never going to allow us to do anything like that again. Okay, so that's kind of our thinking. So as you can see, this is a great stock picture, right? I mean, got it off the internet. I got another one. I got a couple of more. So just be warned, like this one, right? Looks great, right? Who's this? Anyone knows who this is? I mean, it's not a particular guy, but it's a type of a role in the organization. Anyone has an idea? It's a manager, right? I mean, come on. You're a typical IT manager. Come on, look at his face, right? As a suit. So I hope there's no manager in this one. Well, I kind of try to put myself in the shoes of the manager and what they feel about microservices. So managers, they really want to have a grip on things, right? They want to get a sense of maturity and compliancy of the components part of the ecosystem. So in theory, a microservice architecture lets you, it gives developers complete freedom to use whatever tools, languages, or frameworks that they want to use. Okay, but in practice, managers and architects often want to impose like a set of choices to avoid complete chaos. It's not uncommon for managers to tell to developers, like, for instance, you have to choose between a couple of languages. For instance, Java or JavaScript. You can't go to crazy languages which are just released. You only have a set of choices. And there could be goals imposed as well. Like, for instance, the architects could say, your microservice has to have a quality gate installed, and you have to have less than 5 technical dead days, right? I mean, that's kind of typical what they want to impose. Okay, so aside from the technical aspects of the microservice, what's even more important for the organization, for IT in general, is to have these contracts well defined. Contracts between different microservices. If you don't have that defined well, then it kind of becomes this dependency hell. Okay, so you got to be clear on what are the different ways these microservices talk to each other. Okay, so they should really be defined according to a architectural vision and compliant to standards across the organization. Okay, so it's kind of the idea of giving managers a way to ensure that there's compliance and that the quality assurance is kind of adhered to. And something like a dashboard can help them to see which teams are compliant to contract regulations, to choices of tools and such things, and give that insight so they can chase the right teams. Okay, so they wanna kind of invest in the teams where, or in the places where it needs to be invested, but they need to be able to see where it needs to be invested. Where are the gaps in your architecture? So that has to be visualized. Okay, and then for change management, managers are interested in that as well. So they don't only want to see what's currently there, but also what's coming up. Okay, so they want to see, for instance, normally they have this process, change management process. So they have this ticketing system where you have to create a ticket for a release. But with DevOps organization, you don't have to do that because you release much faster, and every team has its own. They need their own release schedule, right? So you don't have to have this cumbersome process anymore of creating tickets, but at least you have to be able to see what's coming up. So you need to have a read model on what's coming in this new way of working with DevOps and with continuous delivery or continuous deployment. Okay, so having a dashboard which shows you this, not only for today but also tomorrow, could really add a lot of benefits for managers here. Okay, so managers, they have their own needs, and if you don't cover them, then they will really start to worry and eventually shut down funding. Okay. So who are these guys? It's another stock picture. What do you think? I could understand if you say that yes, these guys are sales. Business, almost. Analysts, bingo. They have these notes, right? Charts, that kind of stuff. Analysts, right? Well, hope there are no analysts in the room. So analysts, they kind of want to also have a view on things, like what's out there currently. So they want to see the current functional landscape. They want to see which resources are exposed by what microservices, and also what communication is happening between microservices, what events are being sent back and forth, that kind of stuff. Okay, so that's one thing they want to see. They also want to do impact analysis. They want to see if there's a new feature coming up, which teams will be impacted, which teams need to have to be changed in the clients. For instance, for if the servers are changing, the clients have to be changed as well. So they need to be able to look that up and also inform them so that there are no breaking changes deployed to production. Okay, so that's also one thing with troubleshooting. If something goes wrong, they want to be able to see that, okay, it's an application, that application calls this microservice calls that microservice goes to the backend. That kind of flow you want to be able to see. Okay, if you don't use some kind of dashboard, then for that kind of stuff, if they don't have that visual representation, then they also don't have a clue of what's going on. Okay? Especially if you're divided in these different DevOps teams, having this integrated view is necessary. Okay, and then just like managers, analysts want to see what's currently out there, but also what upcoming features are coming up. But analysts also want to be able to give input on what's coming up, because they have a view on the next stories that are going to be implemented. So it would be great to have these analysts, to enable these analysts to give input, also in a dashboard of some sorts, to make sure to tell everyone that there's functionality coming up and that is situated around some microservices. And especially when there's multiple teams working on similar functionality, then it's notoriously difficult to avoid duplication. And having a view on that, that's crucial as well. So for the last, for the last category, we have these guys. Okay, so who are these guys? Come on. Developers. Yes, you see hipster glasses? Developers, right? I mean, that's us. It doesn't look that good either, but okay. We also want to have such a view. We also want to have insights in the ecosystem, because we have to build things and run things now, right? So you build it, you run it, Amazon Credo. So we want to know what's currently deployed. Right? We want to see which versions are deployed, and which dependencies we might have. Okay, because with microservices, it's not just your single application anymore. It's just a landscape you have to interact with. Okay, so that's important, but it's also, it can act as a communication hub. So we can see that, like if you have some kind of tool where everything's integrated with, we can really have a sense of, for instance, API documentation, performance tooling, maybe service registries that we want to integrate, maybe reactive patterns that we want to integrate, reactive insights. All this stuff we can also visualize. And that's key to making sure that we as developers can also understand our own architecture. Okay, so that kind of drove us to kind of build something ourselves, because there's nothing out there currently for this. There's stuff out there for distributed tracing, for service registry information, that kind of stuff. But having this insight in the applications, how they're interacting with each other, that's not there. So we kind of built something ourselves. Now, this isn't the sales pitch, because it's an open source project, but the idea is that this should give you some insight in what is required in a microservice architecture to be visualized. Okay, so we have built a Microservice Dashboard, which gives you 4 columns, which basically show you the layers of your architecture. So you have UI, front-end applications, then you have resources exposed by microservices, could also be events, and then you have the microservices themselves, which are functional boundaries, as you can see. And then you have backends, which could be databases, maybe legacy systems which you have to integrate with, an ESB sometimes. I hope not, but yeah, that often is the case. So this gives you an idea of flows between these layers. Okay, so how do you get this set up? Easy. You kind of just have to create a Spring project, then put a dependency in there, put some annotation, and run it. Okay. Now, if you don't do Java, this might still be difficult. So you can just clone a repository and run it. Okay. This should get you set up really quickly. Okay. So how does this system work? This is basically a UI application which talks over HTTP to a server application. That's really simple. And the server application has these aggregators. So these are these pipes that basically go look into the ecosystem and go fetch information from it. Because that's where we get these insights from. The insights that we need to give managers, analysts, developers peace of mind. Okay, so what kind of aggregators do we have? We have health aggregators, mappings aggregators, index aggregators, and packed aggregators. So the first one, health, it's basically just looking at the health endpoints of your applications. Like, is your system up and running? And it basically can also mention, okay, this application, it calls a database, so I need to know if the database is up. The health endpoint also gives you this information, especially if you use Spring Boot or Drop Wizard or such things. Okay, so it gives you also ideas about your nodes and how they connect to other nodes in your dashboard. So if there would be a database, you would be able to draw a microservice and a database, and you would know if they're up or not and how they're connected. So that's the first one, mappings aggregation. That's basically looking at your resources. Resources are exposed by the microservices, and these or events, and these can also be queried, especially if you use Spring Boot that's out of the box, also with Robbers or other frameworks. Okay, that gives you great information about what you can call on that microservice. Index, that's something derived from hypermedia. And let me ask another question. Who knows hypermedia? That's still quite a bit. Yeah, well, it's not as popular as I would hope, but hypermedia is basically what the World Wide Web is built on. So you have REST, and everybody knows REST, right? But there's maturity levels in REST. You got 3 maturity levels, and the third one is hypermedia, or hypermedia as the engine of application state. So for those who don't know it, it basically allows you to link from one resource to another resource. Basically what you do when you enter a website, you see a bunch of links to another page, right? The home page that you're seeing is a resource, and the other pages are also resources. The links between them are describing relationships between resources, which let you discover other pages. You don't have to know the URLs of all the pages on the World Wide Web. No, you just have to know the home page URL, the host, and from there on you will discover other resources. APIs can do the same thing. Okay, it allows you to decouple your implementation much more, because your service, which is calling another service, the client, which is calling a producer, could basically only have to know the home page, the root URI, and then it can discover the other URIs. So it doesn't have to bookmark URIs anymore. So if those URIs change, it won't break. That's the idea. Okay, so index aggregation builds further upon this idea, where you would have a home page or a index resource exposed by your service, which would then be queryable. And from there on, you could navigate to other resources. So if your microservices are using hypermedia, then it's that simple to create an index on those microservices that link to the resources that the microservice exposes. And from there on, you can discover all that stuff. We can read that in our dashboard, in our aggregator, and just visualize on the dashboard. Now, packed. That's something called consumer-driven contract testing. And who knows about that? Okay, not much. Great. Then at least you'll learn something today. Consumer-driven contract testing is the idea of testing contracts between consumers and producers. Okay, but in a way where both benefit from it. So let's say you have a consumer and a producer. So the consumer is, for instance, a website, HTML, whatever, with some JavaScript in there, and the producer is a server which exposes some REST. Then what you can do with consumer-driven contract testing is that you can have the client or the consumer of the service write in JSON a contract which defines how they are interacting with your service, with the producer. So let's say the producer exposes 10 fields, right? Then the client might only take 2 fields, right? Might only consume those 2 fields. It doesn't care about the 8 others, okay? So if it uses the tolerant reader principle, it won't crash if those 8 other ones are changed. This gives great benefit to the producer, because if the producer knows what services are calling his service, or which clients are calling his contract, then he can also know if he can change fields that are no longer used or that never were used, okay? Which allows him to basically upgrade without having to version. He doesn't have to be backwards compatible if they're not used, right? It also allows him to be able to communicate to clients that he is going to change, so that clients can maybe proactively change or be compliant to what is coming up. Okay, this is a great way of working together. And to the client, this is beneficial as well, because the client basically has guarantee that the producer will not change and will not deploy a version which doesn't work for him. Why not? Because these contracts in JSON, they're put in a repository, and the producer, every time he builds the code, he just takes all these contracts and he runs tests against them. So if there's something changed and your contract is violated, he will not even be able to build it. He will not be able to deploy it. Okay, so you will never have breaking services. Your clients will always be protected. So from both sides, from the client and the producer, from the consumer and the producer, you basically have guarantees there. And this is a safety net for your microservices, because you have constant clients and servers. Constantly you have these consumers and these producers. And being able to ensure the contracts between them gives enormous value in this architecture, at least. So, to come back at the aggregator, Pact is an implementation for this. There's also something called Spring Cloud Contract now, which is recently released by the Spring Cloud team. And it kind of does the same thing, similar at least, and definitely worth to look at. But now we've integrated with Pact, and we're looking at integrating also with Spring Cloud Contract. So this allows you to read the repository where all these contracts are situated, just resolve all this information and show it in a visual way. So because there's basically consumers and producers and contract definitions, what could be greater as a source for a visual dashboard, right? So you can actually see the links between the nodes and what they actually mean. Okay, so these are just aggregators. I mean, you can change them. You can add more aggregators. You can override them, whatever. It's a really flexible system. But what is the system built on? On the server side, so if you remember the architectural drawing that I made, on the right side is a server, on the left side is client. So on the server side, we work with Netty, with RX Java, so reactive extensions. So that makes kind of RX Netty. We have Spring Boot, and we have Spring Cloud. Okay, so that's kind of straightforward. The reactive extensions is just there to make sure that you have optimal usage of your underlying resources, your system resources. If you're interested in that, RxJava has a new competitor in the market, which is Reactor. And Stefan Maldini will be talking about that this evening. So definitely go there. It's about reactive way of working, reactive programming. And Reactor is basically the new best thing in the market. So maybe we'll just switch it out with Reactor. They're very similar in APIs. So this is the server side. On the client side, we kind of built an initial version in Angular 1 using D3GS. But now we're kind of refactoring this. So we are using Angular 2 now with TypeScript. We're still using a little bit of D3GS, I think, for the graph, and with RxJS. Angular 2 comes with RxJS, which is great. And once this is finished, you will see a complete end-to-end reactive flow, which is very neat because it is the most optimized way of working, end-to-end reactive. Okay. So basically, let me demo this. Or maybe I'll go through some slides and then I'll show this in real life. So this is the application. You can filter on it by typing something in the filter bar. You can use also some drop-down filters. Excuse me. Then you can also have errors. So basically, this is the part where managers are concerned about the compliancy and the maturity of the microservices. This microservice in particular, the agenda microservice, talking about agendas, it kind of didn't implement an index. So as you can see, the root URI is basically giving a 500. Yeah, doesn't work. And so this kind of helps managers to see. I'll also show how that's visualized. Maybe I can show the previous slide. Yeah, so here you can see a little bubble, which tells you that there's issues with this microservice. This microservice is not compliant. Okay, I mean, it's not really blocking the microservice from being deployed because you want to have this fast throughput. You don't want to have these processes in the middle, but it's giving insight to managers to be able to push those teams for compliancy. Okay, so that's an important thing because you have all these teams working separately, and you kind of want to have structure imposed without, of course, limiting agility. So these analysts, which I was talking about in the story, these analysts want to kind of indicate what's coming up. So they can add nodes, virtual nodes, as you can see here. You can kind of say, okay, there's a cats app coming up. Okay, you don't have to, if you're another analyst working on cats as well, then you can kind of look at this dashboard once I've submitted this, and you will see that there's a cats app virtual being developed. So if you're thinking about cats, look at that app first. Don't build it yourself, right? Because obviously it's going to be duplicated then. You can of course add links, which will then also be virtual, that kind of stuff, which is pretty straightforward. So that's kind of the main functionality, which gives you this insight and gives you the ease of mind or the peace of mind for the developers, for the analysts, and for the managers. So if you want to get going, we got documentation, obviously, which is pretty extensive. So that's something to look at. I'll give a short demo then. If I can. I think I have to switch my displays back to mirror. Okay. So let me quickly demo this. So if you want to get going, it's really simple. You just go to the GitHub repository. So here we go. Microservice Dashboard, you can Google it. Then here, basically, there's a link to the reference documentation, which you can go to. The reference documentation then has a lot of information about how to get started. But if you really want to get started quickly, you can have where is it? The clone command, git clone. Okay, so we're gonna do that because we want to get really quickly started. So if I clone, it will just pull it from the repository, obviously. Then I go to the samples directory because I want to start a sample so you can guys can see some data in the dashboard, so it doesn't have to go fetch it from somewhere else. And here I will go to the simple mocks because it's built with mocks. Okay, so now I'm in the mocks. I'm gonna call Maven. You don't even have to install Maven. There's a Maven wrapper installed as well, so you can just Maven wrapper and then get it going as well. So I just run it with the Maven Spring Boot plugin. We'll start the application. We'll start an in-memory Redis as well. It will deploy it on an in-memory Tomcat. Okay, and of course all the communication will happen over Netty, RX Netty. Okay, so if I go here, I can now go to localhost. So if you guys want to test this out yourselves, just do the same steps and you'll get going. So here you get the dashboard. I'll zoom in a bit. It's visual, yeah, okay, great. So now indeed, if I want to filter, I can go to pizza. I will see a pizza application. So that's my UI application, which I've built to view my pizzas. I have a lot of resources exposed by my pizza stock microservice, and I have some pizza feedback, so I can give feedback after I ate some pizzas. Great, right? Now, this pizza stock microservice is exposing a lot of resources, and it's going to a lot of backends. Now, normally, you probably don't want to go to that many backends from a microservice, but it's just a demonstration. So here you can see basically what the flows are, and this is great for troubleshooting. Okay, so what I can do as well is I can refresh, and then I can go to indeed, where is it? My agenda. User preferences has an exception. So here you can indeed see what problems are with the microservices, what problems exist. Okay, and then you can as well add a microservice or a resource or whatever. So this is a join 16 test microservice. Don't really have to enter much. Maybe I'll connect it to a backend. Okay, and I'll submit it. So now I have a virtual microservice, which basically calls a backend. So if I now filter on join, I got it. And with the resources, I can add some resources and link it up as well and have an entire chain. So this is for analysts really, okay, to give this insight to the entire organization as well. Okay, so this is to give you an idea about like what's possible with the dashboard. So to come back to the presentation. So the idea of this dashboard is not that you should kind of all jump on this. You can, it's open source and free to use, but the idea is that organizations need to brace themselves for market disruptions, therefore go look at different architectural ways of working such as microservices, and therefore need the right tooling. So if you look at high-performing IT organizations, especially from Silicon Valley, they can deploy 30 times more frequently, 30 times than regular companies. 200 times they go faster from an idea to production. And while they're doing this, they have 60 times fewer failures. And when they fail, they recover also 168 times faster. This is a study from Puppet Labs. So as you can see, if you have to compete with these kind of companies, if they are coming like an Uber, they're coming into your country, they're disrupting the market because the traditional organizations, they can't brace themselves. Their IT organization is not ready for this kind of performance. Okay, so basically, you want to make sure that you have the right tools and the right architecture and the right methodology to be able to counter this and be yourself a disruptor to other markets, to other companies. Okay, that's the key. And this dashboard is basically showing what can be done to make sure you can cope with the extra complexities of microservices. Microservices which makes you go a lot faster as well. Okay, so another stock picture. Promise it's the last one. What's coming up? Okay, so there's a lot of stuff that can be added. We are open to suggestions. There's a GitHub. There's a Gitter. You can chat with us on this. And if you want to try this out in your organization, then we will definitely support you. We had a lot of feedback already from, for instance, Stefan Madrini, also the Spring Cloud team, also Netflix, also Alibaba, for instance. And they also see value in this. So definitely, if you have ideas, bring them. So this is not a single-man effort. I'm here presenting it, but this is really a team effort. The JWorks team on the JWorks conference. It's great, right? This is where we were at Spring I/O in Barcelona, which is a great conference, by the way. We all worked on this together, and it's our goal to just make sure that we don't go to clients and impose an architecture and then leave them hanging or getting destroyed by the complexities, but also build stuff to really brace themselves for the complexities that it brings. Okay, so that's kind of the talk. If there are questions, please don't hold back. There must be some questions. Maybe about microservices or DevOps or anything. Everything was clear? Okay. If there are more questions later, then just yes, one question. I know. What happened? I didn't check it, but it's probably something with Amazon. Okay. Amazon was up. Yeah. Okay, so the question was for the viewers: Netflix went down. What happens? I don't know. But what I do know is that they built their system to withstand this kind of failures. But obviously not good enough. But that's interesting because they once had a failure indeed of the sign-on module. So um, let's say you try to view Netflix, right? And you have to log in. Then you can view your Netflix series, whatever, Narcos or whatever you view, you want to watch. Uh, when the sign-on module goes down, microservices enables them to ask a question to business. What do I want to do in that case? Okay, a question which you wouldn't have in monoliths. If in monoliths, one part of the system goes down, your entire system goes down. Okay, there's no differentiating there. Here you have the different applications deployed separately. So if one of the modules, the sign-on module goes down, they actually have a fallback. They have circuit breakers, which enable them to implement fallbacks. And one of these fallbacks is that it's a business question. What do you want to do when you can't sign in? And they choose to enable streaming for everyone without having to sign in, because they think that's a better approach than having the people who did pay for it and who actually can't sign in now not to be able to view streams. Okay, so they say, okay, now everybody can view them. You don't have to log in. It's fine. Okay, we'll have more traffic to people that didn't pay, but fine. I mean, it's on us, right? So that's kind of the new business benefits of microservices that you can get. But obviously, that didn't suffice because they went down fully. But I mean, that's the idea. That's a mindset. But yeah, there was another failure recently of the CDNs as well. That was a month ago or something. So they kind of built their own CDN appliances as well, just to cope with that. So they kind of want to have complete. They want to shield themselves from any failures of the cloud providers, of the network, CDNs included. So they basically build something in front of it which protects them from it. So they kind of go multiple regions, multiple clouds. That's interesting. So they also, if one of the regions goes down, they have a gorilla monkey in their simian army. So they have the chaos monkeys, and the gorilla monkey just with a bazooka shoots an entire region out of the air, and then the entire region has to fail over to another region. So if you're in Europe, the gorilla monkey came by, the entire region of Europe would go down. You would be routed to US, to Asia, and you'd be able to just stream as well. So that's their philosophy. But apparently never really bulletproof. So yeah. But it's like Netflix is kind of, they call themselves a monitoring company who happen to do also streaming, right? As a side business. Okay. So their video is kind of, oh yeah, we have to do that. But if you look at the way they monitor, if it moves, they monitor it, and if it doesn't move, they also monitor it. So they kind of want to get insights and metrics from everything they do, and from there on, they make business decisions. So that's a new way of working, and that's the most advanced step of microservices. So Netflix kind of pioneered microservices, or at least matured it. They open sourced their frameworks, the Netflix OSS, and enables us in humble Europe to also be able to do microservices. to stand on the shoulders of giants like Netflix, um, and that's just a great example to look at if you want to do microservices. But yeah, as long as you go to the cloud, you will go down eventually. It's like the fallacies of distributed computing, right? Anyway, and more questions? Yeah. Yeah. So the question is, should we always compare ourselves to Netflix, Silicon Valley companies, while we don't have the same requirements. We have smaller databases, smaller user base, and we can just stick with a monolith. It's completely true, definitely. So you definitely have to look at your use case. Do you have to go to microservices? Because as you can see, it's a can of worms as well. So you have all this extra complexity. If you don't have the organization for it, you will be better off keeping your monolith. So if you don't have to go fast, then microservices, I don't know. I mean, it does offer like scaling benefits, but the main reason is to go faster, to have agility, business agility as well. Um, if you have great developers who structure that code in a great way, they apply solid principles, clean code, that kind of stuff, monolith will be probably fine, as long as I mean, the things I mentioned at the start of the presentation, they're still there. So it's going to be longer to go to production. Going to have to be a lot of, I mean, you gotta have a lot of discipline as well on testing. Microservices as well, so that's no difference. But still, with the monolith, it's much more an important part of making it successful. So definitely, this is not a silver bullet. Don't use it for everything. It's also not a golden hammer. It's like, yeah, if you have a golden hammer, everything looks like a nail, right? So not everything is suited for microservices. And there's something from an architect I mentioned at the start. Who was it? Simon Brown, yes, I almost forgot the name. He says that, well, he says this, but he also says that you can have a great monolith if you make it a modular monolith. So if you create packages in your monolith which are functionally bounded, and you don't expose, for instance, your data access layer, you make it package protected in Java. I mean, Java doesn't allow you to restrict a lot, but you can do that. And then you will make sure that only your service layer is being called from your package, and nobody is accessing your schema directly. Okay, and that allows you to also make these contracts between modules clear, without having to pull this module out of your application, putting it on a separate process, and then having network introduced, which can go wrong in so many levels. It's also giving those benefits of having modules inside your application. So yes, indeed, it's sometimes better to keep the monolith. Any more questions? Yes. Yeah, indeed. Yeah. No, that's true. So you accept it. You accept it is not going to be consistent. Okay, so it can also fail. So you don't want to jump into the world of distributed transactions, because the rollback mechanism and all that stuff, it becomes really complex after a while, and you're never completely sure that it's going to be foolproof. I mean, this might still be a specific scenario where eventually your transaction will not be ACID. Okay, so when you want to join different data, which is not situated in your microservice, you can pull in that data from another microservice with a sync job. But then, indeed, you're pulling data from one microservice, but you're not having the most recent data. Okay, so that's that's kind of what you have to work with. Yes, you're duplicating. Yes, definitely. Yeah. Yeah, so indeed, you should work around bounded contexts where you kind of restrict having too many dependencies between two other bounded contexts. You will have overlap, but you try to make that as light as possible. Um, so, for instance, I always give the example of the home idea of home. If you talk about appliances, home is just a key on your keyboard. If you talk about uh, location, then home is where you live. If you talk about sports, home is the home run, the home base. Right? So if you want to put that in your model together, like a traditional monolith should do, you have to put in this nuance of these different domain models, and it becomes really complex because everything can overlap. Right? If you have bounded context, you start to draw lines where you really say this home idea is only specific to this bounded context. Another bounded context doesn't have to know about it. Okay, so the way they interact is really a much finer line, and if you have to really look up data, most often it will be just inside your database. If you have to do more joins, then indeed you'll have this complexity of the consistency, the eventual consistency. But it's a downside of microservices, that's for sure. Yes. So suggestion is an aggregator service. It's possible. Um, yeah, but with an aggregator service, um, it's a bit like it could become like a hype that everybody's building aggregator microservices everywhere. So you have your microservices which have some data, and then you have 100 of aggregator services that just do all kind of combinations and stuff, right? That's dangerous because they're probably going to be used only for one single use case by one single client. So you can look at adapter patterns, that kind of stuff. And Netflix has one of those things. So you have Netflix gateway. The gateway is typical for microservices. It's really necessary because you don't want to have clients know all the different IP and ports of your microservices. So you have a gateway. In the gateway of Netflix, you have Zool, and Zool has dynamic filter injection, where you can add adapters which are specific per client and per device. And those adapters, they aggregate calls for microservices. So they do that aggregation, and they're basically just scripts that can be injected at runtime, and they're compiled at runtime in the system, which allows you. I mean, it could be looked at as an ESB, but it's not, because it's the continuous delivery method used to inject these scripts is really flexible, which means every team is independent of another team. They can push whatever aggregations that they want, and that way, that's a really flexible way of aggregating stuff. That's an option. I'm not saying that's the best option, but try to make sure these aggregations are not spreading like wildfire, right? Okay. Does that answer the question? Okay. Is the other talk done? Because we gotta move that way then. Okay. If there are more questions, please. Yes. Yes. Good question. Um, yeah. So the granularity. There are a lot of suggestions there. You got to, yeah. The way I see it, it should be as big as your head. I think it's not Martin Fowler who said that, but yeah, could be. I think Sam Newman or the other one. Anyway, Thoughtworks guy. Um, so as big as your head, James Lewis, right? So it's big as your head. But if you look at this, if this is your code, I mean, it depends on your language, really, because the verbosity of the language is different. And how much could you write in this? And what font size are you going to use? I mean, this doesn't really make sense. But the idea is it should fit into your head. As one developer, you should be able to understand all the complexities, all the nitty-gritty details of the microservice. And if it goes beyond that, if you need more than one guy to understand the entire complexity, then you're too complex and you need to start splitting or reviewing your bounded contexts. So that's kind of a way to measure it. But otherwise, it's just not too small, not too big. I mean, wasn't that from Sam Newman or? Building microservices? Ah, okay. No. A cache is a microservice. As in the size, complexity, or what? Hmm. Okay. Yeah. Yeah. Well, Facebook is like it's is going doing microservices or picoservices. I mean, that's what I heard. I mean, they're writing like a service is like a bunch of lines. That's the service. They can rewrite it in 5 minutes, and they have hundreds of them or thousands of them. Um, I mean, that sounds like Lambda a lot. Like, yeah, right. So you have serverless architecture as well, and you gotta see where you want to go, how far you want to go. So if you just want to write functions, then you can go serverless. You have a lot of implementations now. I think Bart will talk about it. Not that Bart, but another Bart Blommaerts. Yeah, after me, he will talk about this. Um, and it's really up to you to see what your use case is, how your organization can fit one of these. Well, you can be monolith, you can be microservices, you can be serverless. So you really have the whole span there. And if you're just interested in writing business logic and you don't want to have much control, you don't want to uh, you don't want to change a lot of the proposed infrastructure, then Lambda is probably fine, or serverless architectures, Bluemix or OpenWhisk, sorry, or whatever. There's like Google Cloud Functions now. You have also functions in Azure, I think now. So I mean, there's options there, but that's just functions that are talking with events to each other. But then you have vendor lock-in. That's one. But I mean, vendor lock-in to a certain extent because you can move those functions to another provider, but it's still not really gonna fit that well. I presume. So you have that kind of way, and then everything's taken care of you. Everything's taken care for you by the system that's provided by Lambda, for instance. If you want to have more control, if you want to be able to choose whatever database you want to, choose whatever gateway you want, whatever protocol you want to use, then microservices is the answer. If you don't want to call anything between the services, if you don't want to make any calls, you want to have perfect performance, then you just do everything in process and you have a monolith. Okay, and if you don't want to go fast, then do a monolith. If you're gonna go super fast, do serverless. Okay, there's pros and cons to each of them, and you just gotta choose what's best for your organization. Okay, right. Any more questions? Okay, then I guess it's a wrap. Thanks for everyone for listening.